Hello, welcome to part one of this tutorial series. It's going to be fairly comprehensive and detailed, and it's really just amassing or collating everything into one video for people who want to learn about Arduino, sensors, pure data, and Supercollider, all under one roof. And the first part, purely as a learning exercise, is we're going to build an Arduino, a bare bones breadboard Arduino, using a number of components. Those components are, most importantly, a ATmega 328PU, a CT2102 breakout board, which allows for serial to USB communication, and it contains, importantly, a CH340G chip, rather than the more common FTDI board. I find this one is OS agnostic. FTDI boards really need genuine components, whereas the CH340G will talk to anything under any operating system. I've run them under Windows, OS X and Linux. So these guys are cool. We have a 100 nanofarad cap, an LED, a resistor in the region of 220 ohms. This one's 270. We need a resistor in the region of 10K. This one's 8K2. Two caps here, which are 22 picofarads, and a 16 megahertz crystal oscillator. And the first thing I'm going to do is point out the pins. They're numbered 1 to 14 and then 15 to 28 anti-clockwise on the microcontroller. And I'm going to connect pin 1, which is DTR, it's the reset pin, which allows us to upload sketches using a soft reset. Connect that to ground, to power, to VCC. So that's pin 1 goes to pin 7. I'm going to fly through this because I've already done slower and more detailed videos on how to do this. So pin 1 to pin 7 through the 8K ohm resistor. And next is the crystal oscillator, and that the oscillator pins are pins 9 and 10. So there's pin 10 and pin 9. It's the crystal oscillator. And now we need to put a cap on both those legs to ground. And this is a low pass filter just to make sure that the clock runs on a steady current. So pin 9 goes to 8 and pin 10 goes to 8. That's the two caps in place. So that's it for pins 1, 7, 8, 9, 10. Now we might as well do the LED. And Arduino pin 13 corresponds to pin 19 on the microcontroller. So we go 15, 16, 17, 18, 19. So that's the long leg of the LED. Oh, I've lost 19. 15, 16, 17, 18, 19. Long leg to 19. Oh, come on. Doesn't want to go in. There we go. Long leg to 19. Short leg is going to go to ground via our 270 resistor. That's 22. Ground. Let's just have a check. 1, 2, 3, 4, 5, 6, 7. And 9 goes to 8 through a cap. 10 goes to 8 through a cap. 8 being ground. And then we have another ground over here on 22. And then 22, 21, 20, 19. Yes, that's all good. Now, without which, our CH340G. And the pins on the breakout board are DTR, data transmit ready, RX, TX, VCC, CTS, and ground. That's DTR here, ground here. So I'll just scribble that out on a piece of paper somewhere so I can remember. So the DTR pin is now here, and we need to connect it to the reset pin on the microcontroller via our 100 nanofarad capacitor. So first things first, our reset pin connects to DTR on this chap. And the next pin is RX on this guy, on the serial USB board. Goes to TX, which is pin 1, 2, 3 on the microcontroller. And the next pin on the breakout board is TX. And he goes to RX, which is pin 2 on the microcontroller. I'll put up stills and a fritzing diagram so this is much clearer. The next pin is VCC on the board, breakout board. And then he goes to what we already know as VCC, which is pin 7 on the microcontroller after the resistor. Push. The next pin is CTS. Don't know what it's for, don't know what it does. And then the last pin is ground. Actually, I've got my colours a bit anal about that. Try to stick to orange and red for VCC power. Try to stick to brown or black for ground. There we go. And then the last pin on the breakout board is ground. And we have a ground over here. It's getting a bit messy over there. Cluttered. There's ground. Done. That's part 1 finished. Part 2, I'm going to connect this board to my Linux machine and just run a couple of test sketches in Arduino.